Linear regression consists on a model that has one independent or predictor variable that typically in a graph is in the x-axis, and one dependent or outcome variable which is typically on the y-axis. And the model has two main components or parameters that we are going to estimate, which are the b0 and b1. The b0 is called the intercept and b1 is the slope. And the model has the characteristic, the form of that y hat, so that is what our estimation of the value of y, a value in the y-axis, is given by this equation, which is b0, which is the value here. Here. So the intercept is the value corresponding to y that that corresponds to the value of x equals 0. So when x equals 0, what's the value of y for that regression model? So that's where the line, the regression line, intersects with in the y-axis that corresponds to x of 0, and in this case is here. So 0 is here, and there is where the line is. So that value is, as shown here, 1844. And then we've got b1, which is the slope, and the slope is the change in y as a function of a change in 1 unit of x. So here we've got the estimated b1 is 0.0108. That means that for 1 unit of change of x, so if x goes from 0 to 1, then the value of y that we are predicting is goes up 0.0108 points. So that's not much, but consider that the variable in the x-axis has large number of the possible values it's a large range. So this is hours of practice trying to predict accumulated number of hours of practice trying to predict the expertise in chess. And so 1 hour of practice is not much. That doesn't give you a huge increase, but if you have 10 hours, so if x equals 10, then this 0.0108 multiplies by 10, so that's 0.108. And again, 10 hours of practice is not much, but let's say 100 hours of practice, that will increase 1.08 points of ranking, which is again not much, but 1,000 of hours will increase 10.8 points of ranking, which is decent. And 10,000 hours will increase 108 points in ranking, which is a sizable increase. So that is the slope, and before we explain the intercept. So in this case, we are saying that the intercept is 1844. So for someone without hours of practice, the expected rating in chess is 1844. And then for 1 unit increase in hours of practice, it is expected to increase 0.0108 points. That is the regression line, and that it's a linear regression. Now, how do we calculate the B0 and B1? Okay, so first of all, the regression line needs to have the characteristic that minimizes the total error in the prediction. So if you draw a line from each of the observations to the regression line, then that regression line, so that distance between the dots and the regression line should be as small as possible. So of all the possible regression lines, infinite number of possible regression lines, the one that we are going to choose is the one that minimizes the error. Another thing to take into account is that those values of B0 and B1 could be standardized or unstandardized. So I've shown unstandardized values right now. But standardized values are when instead of using the raw scores, we use z-scores. So we transform the values of the independent and dependent variable into z-scores by subtracting the mean from each value and then dividing by the standard deviation. And that new variable with z-scores will have a mean of 0 and a standard deviation of 1, no matter what was the range of possible values in each of the variables. So when we have standardized parameters, the intercept and the slope, the characteristics or the interpretation of them changes. So for B0, actually the value is always 0, and I'm going to show you why. And for the slope, instead of being an increase in the dependent variable as a function of 1 unit increase in the independent variable, now we are talking about standard deviations. So the slope is an increase in standard deviations in the dependent variable as a function of an increase of 1 standard deviation of the independent variable. So why the slope is 0 always 0 when we have a z-scores? Well, see here, the yellow line indicates the mean of x, the green line indicates the mean of y, and the regression line always have to go through that intersection between the two means. Always is the case. And because in the case of z-scores, both variables mean would be 0, then when x equals 0, y will be 0 in the regression line. So that's the reason why always the B0 standardized will be 0. How do we calculate the slope and the intercept? So in order to calculate the slope, we calculate the covariance of x and y, and we divide that by the variance of x. And then once we obtain the B1, we can obtain B0, and B0 is the mean of y minus the slope times the mean of x. Okay, so now we can show a relationship between some statistics that we mention here or we know from previous masterclasses. So R square has a relationship with the correlation coefficient. Basically, if we square the correlation coefficient, we obtain the R square. And the t-score is calculated using the formula shown in the slide. And why do we need to calculate the t-score? Well, because if we want to determine whether the correlation coefficient R is different than 0, then we compare the t-score we obtained from that R to a t-distribution. And we know a t-distribution how it works. And here we've got the degrees of freedom is n minus 2. Why n minus 2? Well, remember the heuristic. We calculated two means, one mean for one variable x and one mean for variable y. So two means calculated, 2 degrees of freedom lost. So that's why n minus 2 is the number of degrees of freedom. And again, we calculate the t obtained in our sample with the t distribution. And if the probability or p-value is very, very low or lower than a threshold we established, which typically is 0.05, then we reject the null hypothesis that this R score obtained in our sample comes from a distribution in which the R equals 0. Okay, so to summarize the relationship between correlation and linear regression, so they are both part of the same process, but correlation concentrates or focuses on the degree of association between two variables expressed in one number, the correlation coefficient, whereas linear regression is a linear model that predicts the values of one variable based on the values of another variable.